let's go ahead and open up our desktop again. We'll come back to that later. In the meantime, we want to open up Kraken and sort of take a look at what our next feature is. I don't want to work on anything. Well, is that true? We have this improved performance that we're testing out, and the biggest changes that we're going to try is that using GLES 1.0, because if I remember correctly, the Raspberry Pi 4 is GLS 3.0. I don't think it's 3.1, but we can double check that. So if we go to raspberrypi.org, the Raspberry Pi 4 Model B, tech specs, and then down here to the product brief. Here, let's see, multimedia OpenGL ES 3.0 graphics, which is equivalent to the graphics that we get on our phones. So, we know that we can play games on those, and it's pretty good. The previous Raspberry Pi 3 that we had was OpenGL ES 1.1, which was definitely something that you can make games for. But the game engine that I'm using, 3.0, is the bare minimum it suggests. Okay, so we're gonna do this one. So OpenGL ES 3.0. I'm gonna switch back over to here. And we're going to open up initialize. And so here is, we're telling it to use GLES version 3.1. So we're going to switch that to a 0. Everything else should be fine. I'm going to go ahead and save that. And this is using OpenGL ES 3.0. All right, there we go. Okay, so we've got that. I can push you up. Then when we switch over to the Raspberry Pi scene, which we can take a look at, still not even close to done. We can take a look at what we're going to be doing. So we have the improved performance. That's our issue that we're working right now. I'm thinking our next big thing is we're going to have the player fall down the pit. That's going to be our next feature to add in. And we can add this feature in, I believe, without having to change anything else, or at least we can start working on that. If everything just works on the Raspberry Pi 4, then no problem whatsoever. But to show off what this game looks like, before we begin, let's go ahead and assign this to me. Create a branch off of main. All right, we're good there. This won't have any of those like performance improvements or trying to use GLES. It's just using the normal one, but we can take a look at what the game looks like as it is right this second. We can move back and forth, and this is the Pitfall clone. So what I want to do is come over to this pit, stand in it, and then fall through. I might want to make the pit a little bit wider, which is fairly easy for us to do. We can actually use our config.json file. We have a pit width. So we have the pit margin, a pit color, and a pit width. If I take all of these, let's bring them all up again. I'm trying to like slowly make this alphabetized. So pit comes after player, after resolution. There, this is now in the correct order. So pit width, instead of 75, let's do like 125. And so without having to change anything else, without having to recompile, what does this look like? Much better. So now if we come here, we can now be fully inside the pit, and I expect us to now fall down. Now the sort of square outside is the collision detection of our player. So I'm planning on being fairly generous with this. Even if we're like right here, I'm probably not going to have someone fall. I think the main reason for that, like game design wise, is just to help out with anybody who's playing it. Now specifically, this is targeted for my father, who hasn't played games in decades. So this will, like, I think that'll help out a little bit. We're not going Dark Souls difficulty here. So if I'm over it, so we need collision detection now. If I'm over the pit, then I want to enable gravity, and my character falls down. And so that's going to be a state of the character. So instead of running, it'll then be falling. So that sounds like the physics update, the physics system for the player. In update here can choose what their like if it's now going to be in a falling state. Okay, and we have a physics state in mod here, so we're probably going to want to add another one for like falling. Okay, so we'll have a falling physics state. Once we're falling, okay, you're upset because I'm not, checking all the arms here. If we're falling, we're not going to be moving forwards, right? So our self.velocity so it won't really matter. Well, okay, this is going to be important here because if we're falling, it won't matter what direction on the gamepad you use. I want you to like fall down. Already, because like we're going to that sort of isomorphic view. Is that correct? Where we sort of like have the pit on an angle like this, and then the player is standing up, and so we can see their feet over it. We can maybe do collision detection on the bottom part of the feet. If we're on the surface level and we're over the pit, then we need to drop down to the next level down. So when we do our update, how do I want to solve this? probably checking to see. Okay, we need to check to see if we're at the right level. And then also to check to see if we're overlapping over the pit. Which means we need to know if there even is a pit for us to check. So maybe an update here. We have location, we have command. We're also going to need to check the other game objects that are around. And right now, that's part of the map. All I need is like the pit location. So if I were to do something like have pit locations, we could potentially have multiple pits, right? So, but this would have to be an option. And inside of the option, we would have to have like 0.2 F32s. And that would really have to be a vector of those. That way, if we do have multiple pits, this is how we can like get their locations around. This is not really like super helpful though. Because I also need like I need the location and I need like the width and the height of them all. For this pit, game objects for pit here. Yeah, we have a mesh size and we have a location. We could pass in a reference to the pit. And then I would have the location, and we can also add in the width and the height straight into here. That might be something to look at. Well, let's see how this is going. Still going. All right. So if I wanted to get all the pits, probably one of the best things that we can do here is instead of like refactor this, instead of having pit as a separate game object file here, we use in the mod, we have these game objects here. We recreate the pit as a game object, which means we'll have to have a draw system. There's no physics system for that, so that'll be a none. But we could write its own draw system. Or maybe we can create like a static game object draw system. That might be helpful because then it could be the same draw system that's used for all of our things. And then that will be inside of, let's see, in the main scene. In update, we tell the player to update here. So that's just because player is a game object. If I had multiple game objects, I would probably have a vector of these game objects instead. Or we could use a hash map to store the game objects. So like player : game object. And then we can have like pit. But we don't, it's not necessarily helpful because we don't necessarily know how many we need. Like sometimes we need more. So probably a vector would be better. Then once we have the vector of game objects for the player, we could clone the game objects, pass in all the game objects that don't include player, or the static game objects. Like, well, the pit would be static, right? None of the background game objects. Like the trees, or the surface, or the ground. Because eventually I do want to pull those into game objects too. All right, so with that, okay, so that if I had the game objects, like all the game objects here, that would allow me to go to just game objects update. So that would be in game objects mod. Implement game object. So we have our update here. If you have a physics system dot update, and we're going to pass in your own location and your command. But then here we can also pass in like the other things that it needs, like the other game objects. Which means we need a type. So we need to add in a type. So that would be something like a type system here. Then I can have like type is pit. Type is player. Type is tree. Something like that. I think that might be the way to go. So let's refactor first to have the type system for game objects, and then because this is all in the ability to clone the game objects, which will be like a light clone. We'll probably have to custom implement clone for ourselves so that we can only pull in the things that we really want to. Clone that and then pass that in, which really is just going to be like the locations. All right, let's do that. So in game object, okay, we have some tests here that we can run. So a builder to create a player game object. So we're going to want to set the type here. So that's going to be something like in a physics system. We're also going to want a dot type, set type. You're going to have some kind of type for this. So I'm thinking probably like a background. So that means for game objects up here, we pub trait. Here's the struct. Let's do this here. So pub enum game object types. To begin with, we're going to have player. Okay, so set type game object types. Hey, Pretzel. I said no lyrics. They updated everything, and so now it's they have like so many more categories. It's not like quite. I need to go and like reconfigure it. I'm guessing. Okay, there. I have to reset instrumental only. Oh, YouTube safe mode, definitely. Okay. All right, so we do that. You're gonna now air out because we don't have a set type. Also, the player physics system. We're not gonna do that for right now. Self.state. Right. We're also not gonna have falling yet. We sort of figured out where we need to go with this. Why aren't you airing out from the menu? There you go. Okay, so set type. You don't exist, so let's go ahead and add that in. Chantilly, hello! Okay, so mute self. We need to now set our type. We know we need to take in some kind of like my type. Maybe like the new type. And you're going to be a game object type. And guess you need to be reset. You're just taking ownership. You return a new self. Okay, so we can return that. So technically that makes you happy, but let's continue with this. So if we set our type, we now want to assert equal that the player dot my type. I can't use type because type is a reserved keyword. But we can now say that we want you to be the equivalent of game object types player. So now you're saying no field my type. Okay, let's add that in. Okay, you're also saying that we're not setting like a default one to this. So we could state that by default, you're a none, you have no type. That doesn't necessarily make that much sense. Maybe the best default would be like the most things we're gonna have on screen are gonna be those background objects. So maybe like a background. And so we can say that you are my type. It's a game object types background. And so now you're saying you need to be no field my type on game objects. A field are. Didn't I just add on my type? I did. Oh, game object builder. Hold on. Yeah, that also game object needs to have it. This is gonna be my type is a we want you to be a game object types. Okay, so when we build, we want my type to be self dot my type. And now you're saying that you're not implementing standard format debug, and I'm surprised it's not also saying that it needs partial equal. But let's go ahead and implement standard format debug for game object types. And now you're yelling at me saying, now you need to be partially equal. Okay, so it's one at a time that it's yelling at. That's fine. All right, so that's this is showing that it's gonna be correct. We haven't finished that sort of setting the type, but we can run this test and sort of like see it fail. So cargo test that. Yep, it failed because the left is background and the right is player. Okay, so you failed to reset the type. So we can go and do that here. So self dot my type set equal to my type, and then return self. You need to be mutable. And now if we rerun this test, everything should be great. Perfect. Also, while we're sort of doing that, I just noticed that we're done with this. Let's go ahead and switch over to our capture card. System is up to date now. Come on, mouse, work with me. Oh, it's got to restart. That should be pretty fast to restart, though. For the big, I didn't get a chance to sort of see what was on that screen. You're gonna load, right? Yes. Okay. Let's go ahead and we have Git. We do have Git. Okay, so Git phone. This is gonna be. We need to go actually find it. I think that's it. Yes. Okay, so here's the repository that we're caring about. Let's go grab link. Git phone U. CD into jungle. We want to get check out, what branch is that? That is 25. Okay, so we switched to that new branch. Now we want to, and this is going to be the next fun thing that we have to wait for. Oh, we don't have cargo. We need to install Rust. That's next. Instead of Adobe Flash Player, we're gonna go get fast. The wrestling.org. Got it. Okay, so we'll just grab this command here. And run it. Okay, default installation for right now. This shouldn't take too long to install Rust. It's mostly just downloading things. I don't think it needs to compile anything behind the scenes. When we start compiling on our own, that's going to be significantly longer. Chantilly is trying to redeem Pet the Cat as well. I don't think Zilby hasn't wandered in here yet. Not behind the curtain. So Chantilly, if Zilby does wander in, we'll be petting the cat, definitely. So I want to get this installed, like Rust installed, so we can start compiling, because that's going to take a while. And I'm actually really curious, is the fan going to kick on for this? I can feel the fan on, so I plugged it into the correct ports. And I can feel a little bit of heat coming from the case. All right, so we've got that. Let's go ahead and we'll run our source. Now we can do a cargo. Ooh, what version of Rust are we using? Because that's actually really important. Is it? It's show. 1.48. So we learned last time that we have to use 1.47 because there's a bug. There's a bug on Linux for setting up X11. So do rest up, install 1.47, and it's .0. Okay. And then we could also set rest up to use 1.47 too. And then we'll go ahead and start compiling this for release mode, which, I mean, I'm guessing is going to take quite a bit of time. Let's go ahead and, while we're waiting, open up our task manager. You know, installing this isn't as CPU intensive as I thought it would be. But okay, we've that finished. Let's also down do rest up default 1.47.0. I just downloaded you. Why do you have to download again? That seems weird and strange. Did it not download those components right then? Or is it because I said 1.47 instead of 1.47.0 like I did this time? But it was the same version because we saw that it was 1.47.0. One of the nice things, Rust Up just updated, so we should be using the latest Rust Up too, which is, I haven't taken a look to see what the new features that we got were. All right, so here we go. We're now using 1.47. You can do a Rust Up show active toolchain 1.47.0, Rust C 1.47. Okay, perfect. Now we can do a cargo run. Oh, we can't do the release yet. We have to, can I? Hasn't created the target yet. Let's go ahead and get this going. It's gonna fail, but it won't have to like recompile everything once we like copy in the assets folder again. So we're gonna do a cargo run release. And once it fetches all the new crates index, then we'll see the CPU peg way up. Internet's not the best. I put it on the 2.5 network because we got some other stuff running on 5, and I don't want to compete with that. Okay, there we go. So now it's downloading. All right, now we're getting to the compilation. Using all the cores, 99%. Now there's 8 cores in this in the Raspberry Pi 4, and this isn't too terribly bad, speed-wise. Now it takes only about a minute or two on my desktop, but I've got more cores than this, more memory, more everything. But this isn't too bad at all. And the fan's still on low mode, and it's very quiet. So this isn't bad at all. Let's come back to while we're waiting for that to finish. We are currently working on this. So we've got our set. We're able to set our type to be a player now. Now what we really want to do is be able to create a to create a pit. So let's do that. Copy you and add a new test to create pit game object. So we don't really care what the position, the width. You're gonna not have any lives. Config. Okay, so we load the config. All right, so create a new game object with a location, a width, the draw system. So we're gonna want a new draw system for this. So that means before we do that, we need a brand new draw system. So where is that? This is gonna be I think this is gonna be just a static game, a static draw system. And we'll pull that in. All right. I don't necessarily know if we need to store anything in here. We may not. So it could just be a no size struct for this. Now, is that true? I don't necessarily think so. So For a pit, for instance, we need its mesh so we can draw out that square, that rectangle. So maybe before we do this, let's do our test-driven development, because that might help us sort of understand exactly what we want to build here. So big test. Okay, I think our CI test can work for this. We'll find out. CI test creates a static draw system. Okay, so what do we need to actually like draw out from here? We know that we're gonna need the location's gonna have to be passed in, but we need to be able to create its mesh. So we're gonna have to have some like the new something new that creates its mesh in there, or we create the mesh outside and pass that in. And so, for example, a pit, if we look at our pit here is storing the mesh inside. Okay, so that makes sense. Our surface stores a mesh. The bedrock stores a mesh. The foliage stores a mesh. But the player, for example, maybe I don't care about this. Let's just customize it for pit, and then because we have the tests, it'll help us manage this for something else. Raven Legend, hello, and also you subscribe with Prime. You've subscribed for 2 months. Thank you so much, Raven Legend, for the subscription. Awesome to have you here. Thank you. How's your Sunday going? Let's take a look at our capture card again. Oh, our build failed. What happened? Just got a lot better? Oh, that's awesome. Oh, our ALSA stuff. So we need to do, I forgot, we need to install all the Linux requirements for GGEZ. So come on, over here. Oh, man. I need to find a wired mouse to plug into this, because this wireless mouse is on the fritz. I don't think it's blocked any. Just isn't great. What about me? Things are going well. We've got a brand new Raspberry Pi 4. It arrived yesterday, and basically things are looking good. It is the last day before heading back to work tomorrow. But work is good. So it's not bad. It just is. It is a thing. All right. So we want to go to github.com. I do notice that the Raspberry Pi 4, the typing in things is a lot snappier. Like before on Raspberry Pi 3, I would type in a command or like a letter, and it was noticeably slower than on any other computer though. Okay, so GGEZ. And under docs, there is a build for every platform, and we're looking for the Debian right here. So we need to install all of these. So sudo apt install Yes, it should have been done an apt update for us when we did that upgrade earlier. Okay, you're all ready to go. So let's go ahead and do another cargo run release. Looks like we got about halfway through, and it compiled all sys. Perfect. So let's come back here. Let's see. For our static draw system, we know that we're gonna have to have some kind of pit for this. We probably can do a builder pattern. So we can do something like let static. We can call this like the pit draw system equals. We could just use a builder for it, but the builder could be off of the pit itself. So we can do maybe something like static draw system new, and then with mesh, and then we have to provide a mesh here. So mesh builder new dot. In this case, like, it doesn't really matter what this is, right? It could just be whatever. So we can do a rectangle mode. You can be a fill. Bound is going to be a rect. Transform. No, that's not correct. Can you not find rect? You can't even find graphics? Graphics, rect, new. So if I just make something up for this, like, 5.0, 5.0, width is like 25, 0, 5.0. And then our color, we can just use white. Then we build you. What are you upset about? Okay, so mesh builder new, rectangle open, fill, okay, rect, that, close. That's that one. Then we want to build this. Oh, we need a context if we want to create a mesh for this. All right, you're unhappy because we can't do something. Let's give ourselves a new static draw system. Let's at least set this up to work before, because it's not going to give us any good feedback until we at least get this all. Get like a static draw system in here. Okay, so we do, let's see if I have nothing of that. Obstruct, please. Implement. Impl static draw system. New. Okay, so we don't need to take anything else. Return a self. All right, so self. All right, so technically that works now. Now, if I want to, then on top of this, stay with mesh, and then we're going to provide some kind of mesh. Well, That means maybe let's create the mesh up here. So let mesh equals gonna have a mesh builder, new. Can I just build? Pass it in the context. Unwrap this. What kind of mesh are you? Do you technically work? Let's create a mesh so we can do that. That means this cannot be a CI test. So let context that equals mute initialize. Oh, and we need a config. Okay, and then we can unwrap view. Let config equals config load, and that'll be our config.json. And unwrap view. Okay, so that gives us our config. We pass that config in here. We pass in our context, and then we're able to create our mesh. And then we're able to, with mesh. Now, if we want to like make this as realistic as possible, we can create this mesh with a rectangle. It's before the build.
I think everybody needs a friend.
So dot rectangle. Our mode is going to be draw mode fill. Our bounds is going to be a new rect. So you still can't find that. That's wonderful. Graphics. Rect new. And we'll just give it like 0, 0, 10.0, 10.0. Nice little square. We don't really care about this. Make you white. That returns a mesh builder, which we then build and then unwrap, and that gives us our mesh. Then with mesh, and we pass it in the mesh to give ownership to it. All right, so now it's just yelling at us that we don't have a mesh. So what this means for us is we need to like store the mesh in here somehow. Now we can hub function with mesh. We'll take a mute self and a mesh, which is going to be a type mesh. And return a self. And so normally now we would do something like self.mesh equals mesh. Okay. How do I want to do this? We're going to have this be an option. So our mesh is going to have to be an option.
I think everybody needs a friend.
An option mesh. Which means when we create this, mesh is a none to begin with. And then you are going to be self.mesh equals mesh, and then return self. And you are going to be a sum mesh. Okay, so that should make that happy. So these tests should still pass. We're able to create the new mesh with this mesh. Given that, I don't know if there's anything else we really need to care about with this draw system for the pit specifically. Then we're going to need to... So how can I assert equal, like the meshes are the same? So can I, for example, clone this? Yes, okay, I can. And then can I assert equal that the pit draw system dot mesh is equal to mesh? I don't know if they... let's see. Dot unwrap. You're not telling me that it doesn't work. Let's try running this. Hey, that works. Okay. So we can test now that, hey, we're able to create this. And while it might not feel like the best test right now, the biggest thing is when I make changes to this, it'll let us know like, hey, we have to, does the test still work? Does everything still work with this? Since we finished that test, let's go take a look at our Raspberry Pi. Oh, it's so close. I move off to the side. We're 300 out of 302 packages. We're so close to getting this running. Now it's going to crash because I don't have the assets set up for it. But we can get a symlink set up as soon as that happens. So we're really close. We'll come back in a second for that. Okay, so we're able to get a draw system now. We need to implement the draw system from the mod here. So impl draw system for static draw system. All right, so we have the function draw. We'd taken the images, the config, the context, the location, the physics system, and the life system. Notice a lot of these are options here, so we don't have to worry about that. And in this specific case, because it's a static draw system, all I want to do is just draw the mesh out using this location here. So we're going to do a graphics draw. Okay, so passing the context. This would be a self.mesh. And then any drop params, yeah, we need to translate this over into the correct spot. So draw param new dest, and that's going to be our location. And it returns a game result, so that's it. The trait bound option, because GGE, okay, because the mesh is an option there. So if let sum mesh equals self dot, and you can be a reference to self dot mesh here. Now you can just be the mesh, and you're going to return this, else return okay. Now dest, that's because location, well, that's a 0.2, so that's fine. You need to be a reference to that. Oh, you need to be converting. And I don't think I can do an into here. I think I have to manually set this to essentially be an array of location.x, location.y. And that makes you happy. All right, so then like we've implemented draw system here. And that means we can now come back to, so your public and mod draw systems, you're a pub mod. Okay, for game objects, we can now recontinue you again. So our draw system for a pit is going to be a box new. This is going to be well, we have to create it. So we're using the builder pattern for this. So this is going to be let pit draw system. Can you not find it? You can't find it. Failed to resolve. Pit draw system. Okay, so we have. Oh, right, because it's a static draw system. That's why. Ah, don't do that. Back to. You're a static draw system. New. Dot with mesh. And then we have to actually create the mesh here. So now it makes me wonder, should we, similar to images, have like meshes and images be in like a single struct? So instead of images, it would be drawables, like our drawables. And then at the beginning, when we first load up, we just create all of those one by one. And then that might work out really well, because then we could have like, okay, the draw system uses that image and it just could be a string, and that can just extract out. Might be helpful. For right now, I'm gonna do like to create the actual pit. So pit mesh, it's gonna equal to, and that kind of sucks because like we have to now, this can't be a CI test anymore. Now what did you do? You're using a CI test. You have a config and a draw system. A new one there. Because it's only on images when it draws. Trout Soda, hello. To be honest, I don't know enough here about games. Games are fun to make, but also like they scale and they get hard to make. But I think that's a good challenge, and I'm still very new at making games myself. So we're all learning together. And so like I'm trying different architectures to sort of see if any of them make it easier for us, or at least better for like, growing bigger, going faster, less bugs. Okay, so if I create the pit mesh, and I kind of like, this kind of makes me feel like I do want to have just like images, refactor that to be just like the drawables holder. But we'll do a mesh builder. New. We'll do a rectangle. Draw mode. fill bound is going to be a rect 1.0, 0, 1.0, 0, really tiny. Make you white. We'll build, which means we need a context here. Unwrap. So context u equals mute initialize and pass in a reference to the config and unwrap you. Okay, so that gives us our pit draw system. We pass in the pit mesh. Okay, so that gives us a static draw system. And so here in our draw system, it's a box new. And this will now be the pit draw system. Okay. Life system. So pits have no life system. So this can be a, this is going to have to be a none. Or rather, we don't do this at all. We just don't call life system. Physics system. Pits don't have physics system, so I don't need to do that. Set type. Okay, so we want this to be like the type of pit. So set type to pit. And then we build, and that gives us a pit. So then we can assert that this pit pit.location is the same as like what it says. The width is the same. And the type is set to pit. And the pit life system is a none. So we don't expect. Can I assert equal that? So assert equal that the life what is it? Pit dot life system is the same as a none. And assert equal pit dot physics system is a none. Okay, so cannot be applied to type option. Oh, okay. So I can't like set there's no like partial equal for none, essentially. So we just don't have to do that. Then we should be happy here. We should be able to run this test. All right, perfect. We saw that flash the screen. That's why we can't do a CI test here. Now we're able to create a pit game object. So then I want to store all the game objects in a vector. So that way we can have like the player as a game object and then a pit as a game object right together. Before we do that, let's go ahead and take a look at you. Panicked on resource not found. Okay, so let's go ahead and fix that. So we have and you. Okay, so I think I could just do it from here. So ln dash s resources, and I want to link that to target release just there. Oh, file exists, right, because it created a resources, but there's nothing in it. So we want to remove directory target resource release resources first. Then we do this again. So if I do an ls-al target release, there we can see the resources is linked there. So if we do another cargo run release mode, resources not found. Apparently that was incorrect. ls target release resources. Oh, that didn't work out the way I wanted it to. Okay. Remove target release. Let's try this again. I'm going to cd into target release first. We're going to do... Okay, so we're in target release. We're going to create a ln-s, go down to get resources, and put it here. And okay, that's what I was looking for. The much better sort of look to that symlink. And we'll do our cargo run release again. All right, we're running. That came up a lot faster too, which is a good sign. And it's definitely running faster, but not. Not like exactly what I was hoping it would be. If we close you out, what was our... That draw is still 223 milliseconds for that draw loop. Which is not the best. If I check out the main branch, make sure we're up to date. I think we are. Yeah, so recompile the main file because some things changed in there. But we were doing a whole bunch of things messing with this. Now there's some optimizations that we know we can do. One of them is to switch over to using images a lot more rather than the meshes. Yeah, okay. Oh, some of the other things we can try. We wanted to... The Rust... What was that command to get the info? Oh, I forgot the there's the Raspi config, Raspi info. I think that helps. The Raspi config might work for us. Is it dash config? It is dash config. All right, so we want advanced options, GL driver. Okay, so I think right now we're on the legacy non-GL desktop driver, and so we want this one. Really? You're not going to require a reboot? Okay, let's switch back to... I'm surprised it didn't tell me I needed to do a reboot. There. Check out... What was... 25. I probably need to do a reboot anyways. I bet it's lying to me. Linux never lies. I wish. I wish. Okay, so it runs. The same look. And the same really slow. Okay. Let's close you up. Now it's 101. So that like cut you in half. Oh, I remember it was like the Mesa utils. We need like the Mesa utils. But let's try a sudo reboot first. And when that comes back online, we'll try this. You too. You just got a Pi 400 set up with Ubuntu desktop. It's working pretty well, other than some Snap Store issues. Which Pi did you get in it? Is it the 8 GB model? The 400 is that keyboard, right? It's just like a keyboard with the Pi in it, and like that's the entire computer. Oh man, that is a really fast reboot. It was slower last time with the Raspberry Pi 3. I'm wondering, do I know where my USP might be worth it to see if I can find it. Here it is. So I have a different mouse that I could plug in here. Yes, keyboard form factor, you think it has 4 GB of RAM. I know they have the 8 GB model too. If I was going to try to do any kind of like desktop replacement, I would definitely get the 8 GB model. And then having that run in like two different displays and like using it as like a light programming system, especially if I'm like traveling, that could be really fun. Like essentially creating our own laptop. All right, so I should now be able to use this mouse. Oh man, this is so much of a better mouse. Okay. CD to jungle. And rerun you again. Yeah, still that slowness here. And that's getting 114 milliseconds. First thing when you install Ubuntu is to remove Snap. I know Snap does seem to like slow everything down. Okay, so we can definitely make things run fast again by having images, and we can get like 7 or 8 images at the same time before things like get really slow. but it's not. I was really hoping this would just like work out of the box, and it'd be really happy. If we take a look at VI, what was this? It was the source initialize. We can see here. Okay, let the backend is GLES version 3.0. Windows setup. Okay, then use the backend here. I wonder, do I have to? Nope, that's the wrong one. Nope. Try again. I'm used to the other keyboard layout. Okay, so let me try putting the backend at the beginning. I don't know if that matters. Oh, yours is the 4 GB you ordered from SparkFun since they're nearby. Didn't see 8 GB options. Why is it slow? I don't know why this is slow. This is one of the things that we've been like really concerned about and very sort of like confused by, because what my game is doing should be fine, even if I'm not being very efficient with my meshes. Just drawing like 8 of them out, like creating and drawing 8 out to the screen should be fine. There is a profiler. I just don't have it on Raspberry Pi. I need to figure that out. And we did eventually figure out that the problem is in the draw loop. Actually drawing out all of these meshes together is our problem. So one other suggestion. No, that's not too bad. That was 20 milliseconds. So we take a look. We have microseconds, and then 20 milliseconds. 20 milliseconds. Okay, so that's 20 milliseconds is within our time frame, because we have around 30 milliseconds to stay at 30 frames per second. Oh, check to see if it's using 100% CPU. Yeah, before it was using 100% of the CPU. Let's see if it still is. Oh, interesting. Look at that. It's not anymore. It's... Oh, wow. Like 3%, 2% CPU. Memory is down. Okay. So we're successfully using the GPU. Is there... Okay, this is nice. For the task manager, yes, you're correct, Shershock. For 60 frames per second, we should not go past 16 milliseconds. Is 16, well, 15 dot something. But I am gonna target 30 frames per second to give myself a little bit more time. Plus, with this game, I don't think it really matters to like have 60 frames per second. But our CPU usage is way down, meaning that we are using the GLES, GL just fine. Now, is there... Heck, it's 0%, 1%. It's hardly anything. Um, can I see graphics? Uh, how would I show like the graphics usage there? Because that should be a lot higher. What is the bottleneck here? I'm not sure anymore. We know that it's still in. All right, we can switch back view, view wider. Okay, that one was 264. $255. If I'm just standing still. $311. Oh wow, okay. And is it with that? Maybe check view if it shows how much GUI is being used. What do more details give? All right, what did that give me? Wait, did that take away details? That just took away details. Did you install GPU drivers? I just went with the basic ones. I don't. Probably not. Let's see. What were the GPU drivers? How did we get that installed? Let me see if I can remember. We had. And. For the GPU is opt vc bin vc debug reloc stack. The RAM usage was way down, like was very low, so we weren't pegging that at all. So there shouldn't be any swapping. Let's see. What is this? Slash opt vc bin vc debug. Oh, permission denied. No command specified. F, I guess. No command. Well, what command do I want? How do I... Okay, you're not going to tell me what the command options are? Just... Fine. Or use vcdebug help command name to get help on a particular command, but it doesn't give me a list of commands. Fine. 3-m for RAM usage. Okay, you can use sudo 3m. And I can run that while we're playing the game too. So sudo 3m. Okay, so we can see memory and swap is not too bad. If I open up U, we start drawing out all the trees and the background and everything else. Or we run you again. Like still not that bad. We move to the next scene. Still not that bad. So that nothing's really changed here. Okay. Oh, relax stats. Like those are the commands, isn't it? Yeah. All right. So let's do slash. What is it? Opt. PC. Bin. PC debug. Relock. Stats. Sudo that. Okay. Locations. And we can do a dash F, I think. Keep that auto reloading. No. It's not bad. 40 megabytes free memory in one block. Okay. That seems to be fine too. Okay, so the next thing that we were trying on Friday, and I think I forgot to save it away, was check to install like the Mesa utils, and I forgot exactly which one they were. So that was the Raspberry Pi. We want to essentially install OpenGL or activate OpenGL on it. We can install some of the Mesa drivers, maybe. Oh, and we could try to set up the GPU memory to make it a little bit more. So let's see. Raspi config. For that link. Okay, so that link is this. Well, it's an update for them. The GPU bundled with Raspberry Pi 4 is a Video Core 6 capable of OpenGL ES 3.2. Oh, maybe I can do 3.2. The driver code for both GPU models is available in the Mesa upstream repository. Okay, so let's go take a look at this. Now, if I want to install these, I don't want to build them from source. Is there available from apt? So can I do... Well, first of all, okay, with this, display options, interface options, performance options, GPU memory, we can set this to be the maximum. So 256. So that could help out with that. For advanced options, we could also enable the compositor. Okay, so we're doing that. Yes. Okay. Okay, let's reboot. Yeah, I know. Oh, okay. You have a link for precompiled. Is it part of apt? Do they have it in their repositories for that? In general, precompiled Mesa libraries are not available. Some links. Oh, this is from Mesa itself. That, I wonder if Raspberry Pi includes their own. So can I come back to here? We'll open up this. So I'm curious, can I say sudo let's update first, make sure we do have the latest here. And then what if I can just do like Mesa tab and we'll just see what our options are from that. Sudo apt install Mesa. Okay, so we can do any one of these. So VD POW drivers, the Vulkan drivers. I didn't even think that Vulkan was ready for this yet. Huh, which one should I try? I have no idea which one I want to try first. Let's VD POW drivers. VA drivers? Yeah, let's try that one. VA drivers. Let's just go from top left, the one that has drivers in the name, and we'll just try each of them one at a time. Okay, drivers is already the newest version. Mesa VA driver set to manually installed. Okay, so we already have that. Okay. So let's try. In that case, I don't think it would have helped because we already have those drivers activated. We probably want to try the VD POW drivers. Okay, so I don't think I want to uninstall it. So VD POW. POW drivers. Whereas our game is not using, I don't know. Because that's GGEZ sort of like is trying to do that kind of stuff behind the scenes. Okay, we already have all these drivers. We already have them all, huh? What's the Mesa utils? We can install the Mesa utils. And maybe that'll give us a little bit more information. So with Mesa utils, we've already installed all of the drivers. Bad news. Uh-oh. Uh-oh. I don't like to hear that. Well, okay, that's ES2 support, but this new one has ES3. So it should really work with this should work with it should work for us because we have ES3 now. Because if you come back to here, what is it? Mesa. I want to Linux check GL check version of OpenGL. And that is GLX info. Right. GLX info type grep version. We can see here OpenGS 3.1. We can try setting our code to use OpenGL version 3.1. So PI jungle. We probably need to reboot anyway, so let's just go ahead and get that done. After like a whole bunch of those changes. And we'll use the drivers for 3.1 instead of 3.0. Now we do have a workaround, which is to switch things around to create like the images, and use images instead of meshes, which is significantly faster. Okay, cd jungle. I guess first of all we could just try running it as it is. See if anything that we did made any difference. I mean, it feels a tiny bit faster, but not really. We can see there 15, 21, and it was about to be really long. It's OpenGL. I think it is OpenGL 2, but we're using OpenGL ES, which should be different. I think that should be different. Okay, so by VI source. Initialize. Okay. Switch you to 1. Nope. Sure, why not? Recompile and try this again. I think it's OpenGL 2, OpenGL ES3. But we can run that GLX config. I did save. Yeah. That's why it's taking longer to I did the Shift ZZ. So capital Z is quit and save in VI. Microsoft released an ARM version of VS Code that runs great on a Pi. Ooh, that might be interesting to check out. I don't think the amount of memory we have here is good for this. Feels like about the same speed here. And if we take a look here, we're 23 milliseconds, 23 milliseconds, 316 milliseconds. So a whole bunch of milliseconds there. And then we're holding steady back again with like 300 milliseconds, aren't we? Yeah, 367 milliseconds again. That's not the best. If we go back to our GLX info, I just run that. Oh, that's too much. What other information do we have? Nothing helpful. So this is ES 3.1. With OpenGL 2.1. So we could try just OpenGL 2.1. There is that sort of error in there, but maybe this will work. Try PI source initialize for our backend. We'll do GL 2 save and quit. Okay, so 2.1. And so while that's compiling, what is yeah, okay, so that's failing to open it up. And so then we do, at least you can look chat due to long compilation time. Yeah, exactly. Sudo, it's the Raspberry config. Do for the advanced options. Like nothing else was sort of set up for us. So we still want to use this fake. Now we have less options here, even though we have more drivers. And so it does make me wonder if, do we have any weird problems where it's not like active? How do I have to activate those drivers? Of like, what is the primary one using? Yeah, I don't want to use legacy. We're using this GLL. We're using this one. Oh, what is inside performance? Yeah, let's go take a look. Performance, CPU overclocking. We don't need to do that because we're using like 2% of the CPU. GPU memory, I've maxed that out to 256. And there's not really much else that we can do here. Let's see. That's just an update on the drivers. Maybe Maybe is there something where I can like activate drivers? Or we can try. I could try like installing Ubuntu essentially, and seeing if that works. And then now those other drivers from Mesa. Yeah, maybe try that. That probably won't be on stream because that will be a really long time. Sure, let's reboot. Who knows if it works out of the box? I don't know. I might need the the 4 GB version of Raspberry Pi in order to run Ubuntu 64-bit mode. But I could run 32-bit mode, I think, on the current one. I could also run like the light mode here. And we can also try just installing the rest of those Mesa drivers just to make sure that they actually are all really installed. If we first go to Jungle, make sure it still is not doing the exact same thing. Let's take a look. Right, we are currently not using the right one there. It's like that's not working. That's VI again. Now I could also not use the backend. And then let it try to use whatever the default backend that it's trying to do is. Which I think is like, I think it's OpenGL 2 dot something, 2.9. But yeah, okay, so it fails to open up the display. It doesn't know how to. And that's not too terribly surprising. We open you up. Bring you back. Reset you to not that. Undo. DLES. This becomes 3.1. We're using that backend. This should still have the same problem. We could try. I don't know if those other Mesa drivers are installed or not. They probably are. And then for, okay, there you are. Same problem here. Now we can also set up the config and draw just a lot less trees, and that might make it a little bit happier. But if we come back to this, we can still see that our CPU usage is really low. We're not even coming close to maxing our memory. So it's not bad at all. Like we know we're using the graphics card now. So that's good. Then let's vi our config that JSON and remove some of our trees. So we have the tree count here. Let's see, tree, trunk color, height, width, count. So instead of 9, let's make this like 1. This shouldn't need to recompile. It's just going to draw less of the less of the trunks out. And we can see it's faster, but it's not that much faster. And we can see we're down to like 150 milliseconds. I cut it in half with those trees. So should I write down all of our options and then choose one by one? I think like what we verified last time is we have significant savings if we switch over and use images. Like instead of creating actual meshes and displaying those out, I actually go into Sprite and I draw a tree, like just a single tree image with the branches on it. That would be a huge savings for it. The other thing is we could see if GGEZ allows us to combine all of our updates into one when sending it to the graphics card. And that would potentially help out a lot too. But I think it's really just if we come back to our main code, I think it's mostly just our calls to draw. We're doing too much. So if we take a look at, we start with the main scene. In draw, we're doing, heck, let's just start at live. In draw here, and might be better, let's save these changes. So work in progress. This is falling into the pit. Switch over to this branch. Okay, so in draw, we're tracking our time here, so we can see how long the draw loop is taking, and we're able to see, okay, match of the active scene. If we're in the main scene, we tell the main scene to draw. We present, and then we're also doing this thread yield now, which should be helpful. It would require another package, but you could add flame to figure out what part of draw is taking so long. Oh, to do like the flame graph. Yeah, we could do that. Then if we go into flame graph, so we go into there. So main scene, we go into this draw. We see that we actually need to go to main scene here. Here's draw. We're telling it to draw the map, and we're telling it to draw the player. So, when we tell it to draw the map, That's telling it to draw the bedrock, the ground, the surface background, the tree trunks, and the foliage. That's a lot of individual draw functions to write out, and then draw out this pit if it exists. And for each of those, if we go in and take a look, all that it is doing is like bedrock draw. We go to bedrock. Game objects, bedrock. Here's draw. It's just drawing its mesh out. So we're not creating a new mesh. It's just drawing the mesh that it has out onto the screen, which doesn't seem like it should be too terribly bad, but something that we can do. And that flame might be helpful there. Yeah. There's also cargo profile that we saw recently on Reddit, shared on Reddit. And that could be really nice too. And does cargo profile support flame? It might. That might be something I do off screen. If we were, but I think the map is like just taking up a really, really long time here. And the easiest way for us to verify that is I could vi source I think it's scenes, main scene. We'll go down to draw. Where we have this self map draw. We just comment that out and rerun this. And we'll just have the player, we could still move the player back and forth. But I think what we're going to see is remove all the things. We're going to see a very fast game. Our other choices is also to reduce the resolution on this by quite a bit. Right now, this is 1920 by 1080, and we can make this a lot smaller. But yeah, so here's, oh, this is actually pretty slow. I was expecting this to be a lot faster. Come down, we'll see, oh, 70 milliseconds. I thought we had tested that it was faster than this, but like significant savings, but still way too slow. So what's happening inside of player? Inside of player, so let's see. We have the game object. So in a game object draw, all we're doing here is saying if you have, let's see, self the draw system to draw, and then pass in all the things. We're not cloning, we're not doing anything else though. Don't remove the game though. Exactly, yeah. So if we go to our player draw system, we can see what we're doing here. We are we're doing the animations for the player, and then we're drawing out which of the animations for the mesh, for the image sprite sheet that we want to. And so we can tell we're passing in images here as a reference. So we're not having to recreate or reload the image every single frame. Instead, we're just sort of like grabbing a different view of it every X frames. And we're figuring out which, like the timing of that is all being stored internally. And okay, so we can see get the image, which is a reference, so we're not cloning it. And even so, cloning the image should be cheap, because it's really not like in GGeasy. It should be cheap. Drop param. Okay, so we're figuring out where we're gonna draw on that image, like which part of the image we're gonna share. If we have a physics state, we're gonna figure out our physics. If we have a life system, we're gonna draw out all those lives. Each of those life hearts is an image that's being drawn over and over again. So we could, for example, try not drawing all the hearts. And then if I do that, not drawing the hearts. Push that up there. And down here. It's can we do a get pull? May have made some changes. Oh no, I didn't make the changes in the same place, so we don't have merge conflict. Perfect. And rerun this. So this is without the hearts in the top right of the corner. So I think we verified that we can draw like in the Raspberry Pi 3, like, I don't know, 7-10 images, and still be like within 60 frames per second pretty easily. As soon as we go to like over that, we start losing quite a bit. So this is a lot faster now. And that's just without drawing the hearts. So if we switch back, we'll see that we're at, our draw is now 22 milliseconds. So that's within, that is within the 30 frames per second limitation. So maybe we can't draw hearts out to the screen. Now, out of curiosity, oh, I just quit terminal. That's not. Out of curiosity, what if I made the resolution a lot smaller? I'm actually really curious. What is our resolution rate? Let's do so. Pi config. Let's take a look at display options, resolution, monitor preferred resolution. Okay, so we can set it to. We can set it to 1920 by 1080 at 30 hertz, which is exactly what we're doing. If we do that, if I do that, and I wonder if like would VSync start working now, or would that still be bad and not work? Well, there was a website that Denny Fritz wanted us to go to show off the OpenGL and if that was working. And I can't remember what that was. So everything is looking the same still. We're at 1920 by 1080 native. And I think OpenGL is set up on, so let's see into jungle. I think you already pulled. Let's see if we get any savings here. Our draw is taking 33 milliseconds. So that's slightly over 30 frames per second. Slightly under 30 frames per second. So it's a little bit too slow for us still. Now our other choices, we could set a resolution to lower and then reduce the resolution of the that the Pi wants to do. So we could do vi config. Now this screws up a little bit of our resolution things here, like where the title is, but that's because we didn't properly use ratios. So that would have probably been good for us to do, but USB was warning us, and if we make our game somehow thing really small, like 800 by 600, that will definitely work. If we do 1200, okay, what's I need to look up what are the different ratios for 16 by 9. 16 by 9 resolutions. So we're at 1920 by 1080, which is full HD or 2K. We can move down to 1600 by 900. 1600 by 900. And just run this exactly as it is. Which doesn't look too bad, and we're down. That's exactly the same. It's exactly the same frames per second. So no savings there. Let's say we go all the way down to let's see. We can do 1280 by 720 might be the lowest. Sig was taken. Hello. Can you call me Brookie? I mean, I guess you could. Over here, I go by Brook Circle or Brooks usually. Let's try 1280 by 720. I hope I'm doing well. Well, thank you very much. How are you doing? Let's see how this is feeling. The player is way down there. I mean, this is looking a little bit better. But we're still on 33 milliseconds. So our resolution isn't affecting us at all. Our resolution is just fine. It's now our we're just trying to do too many things at the same time. So that's actually really good to know. We can stay at the 1920 by 1080 resolution, and we need to do less draws. So to fix this, let's create a lot less meshes, maybe even no meshes if possible. Let's see. You've been dying to ask, what are my thoughts on the new Apple M1 chip? So I don't have one myself. I haven't been able to play with it. But early reports from people that I know who have been using it, which is 2 people, they power usage. Basically, they're able to run a MacBook Pro, the 13-inch model, for days while working on software development. So power usage is really nice. they were also reporting that it was faster than they expected it to be. And I think that's because Apple has rewritten a bunch of the LLVM optimizations for the M1 chips just on its own. So there could be a huge amount of savings for there too. Now Rust development, who knows? Um, I know Rust is using LLVM uh, natively for compilation, but does that really mean that we're gonna see the same compilation savings? Now, running wise, I don't think we're gonna have any problems, right? If we compile it to the M1 chip, it's gonna run really fast and really well. That being said, if it turns out that basically the M1 chip is as great as earlier reports are showing, it's gonna be really hard for me to say no to a MacBook Pro 13-inch as my next notebook. Mainly because my other computers, I was looking at the price differences of the Apple tax. Well, it turns out there's now a Dell tax. There's an HP tax. There's an Intel tax. There's a IBM tax. They all when we go up to the level of computer that I want, with the right amount of RAM, with the right amount of graphics systems, it just ends up being costing almost the same thing, only a couple $100 difference. So at that point of time, it becomes less compelling to go with something else. Unless I want basically to buy a Raspberry Pi 8 gigabyte and just go with that. But this is not making me feel super great about that. Then again, it might be the operating system. It might be the Raspbian operating system hitting us too. Anyways, yeah. Trout Sody, the M1 Mini comes out next week. Are you gonna get the Mini? I haven't used an Apple Mini since I was a sysadmin in 2014. So that was a long time ago. Sig, what are your thoughts on the M1? Are you thinking about getting a Mac? So before I move on and do our draw system, now that we know that we're having problems with this, I think we need to continue on with our performance improvement. You're too poor? Oh, I'm sorry about that. The MacBook Air is looking pretty good. And it's cheap. But with all of the higher end computers, it's the low end of the higher end computers. Oh, you ordered the Mac Mini. You've been on Windows for about 5 years, after Mac for almost 8 years, so you're excited to be back. Nice. You can stick with your laptop till it fails, but you'll definitely consider Mac in the future. Nice. Yeah, I think the best thing, I'm really hoping that within the next year, my work refreshes my computer and I get an M1 MacBook Pro, because that would be amazing. Yeah, and if your computers are tools, right? We can get excited about getting new devices and playing with them, but if it's working for us, then there's no reason to switch. All right, so what I want to do is I want to switch over and open Sprite. Can you not find it? Oh, because you're Sprite. Apps. Nobody told you to open up. Where is Sprite? Where did you go? I know I installed it and we ran it before. Okay, Okay, hold on. Let me see if I can find it. A Sprite, where did you go? I ran the installer. Did it like somehow delete it from my system by accident? Oh, does it not have an installer maybe? And like I just was leaving it in my downloads by accident. Let's see. Would it be in my users, app data, local programs? Oh yeah, I think I accidentally deleted it. Hold on, I need to go find the re-downloader for it. I saved that email to grab it. A Sprite. There is the URL for this. Go re-download it. Oh, you're right. It's on. I have it on Steam. That's where it is. It's on Steam. Okay. Open up Steam. Wait a second. I don't see it on Steam here. Games, tools, software. There it is. Okay. Here it is. A Sprite. Launch. All right, so let's do a new. So I want this to be 16 by 9, so I can do the entire background all in one go for this. So if we take a look at our aspect ratios, we could just do the smallest, which is 256 by 144, and that should do it. So 256, 144. We can do indexed, and this can just be black background. I think that'll be fine. And so here you are. I definitely don't need that bottom panel. You can go down like that. All right, so I want something like, and for that, we're gonna do, where's my toolbar? There you are. I keep on thinking that this toolbar is over on the left, so I look for it over there, but it's not. It is over here. So rectangle, build rectangle. I want you to be something like that. Now, I should be really... Can I actually set you? Oh, once I do this, I'm done. Can't move you around anymore. Oh, that's not the best. Mainly because I wanted to be very specific with how many pixels tall this is right here. So when I do that, font size, color tint, and also where's my layers? Was that down at the bottom? There, edges, selection edges, grid might be helpful. Okay, you're 16 by 16. Okay, so it's 16 pixels for each one of these. So if I do a full one of you and we basically set you to be 16. And so we set that. Then we have our cave, which is another 1, 2, 3. Well, like double that. Oh, see, this is too much. Like we need this to be a lot smaller. And I don't think I can do that there. I need to learn how to use a sprite for like select this. Oh, that's not right. Okay, contract. Okay, hold on. Let's do a select. And none of those are exactly what I want. There's the move, eyedropper, eraser, pencil. Okay. Oh, magic wand. So I can select you. Here we go. And now this is where I can set this to be a lot smaller or a lot higher. And okay, this is where I can see that it's 130, 149. That's the position of where it is. We're going to see the height. Okay, that's that number right here. Set 16. So I can set you to be like 5 pixels for this. Then we're gonna have a cave, and we might want to have the cave be like some certain amount tall. Then we're gonna want a filled square, and this is going to be the same soil as here. No, just slightly darker. So maybe something like this. Maybe we want to go there and do it just a little bit brighter. And we'll do another selection. And then we'll set you to be. So you're 5. I think we can do double that, go to 10. And we can do something like this. This is going to be our cave. Maybe even like down to here. Here's our cave. Here's the soil, as it were. We can have the same feeling. Here, what are you? You are U. Create you again, and what are you? You are W. And I want you to be like 15. So it's bigger than this, but not too much. And then I think I could turn off that grid. View. Okay, so we have our cave. We have like the what did I call it? The bedrock. So the bedrock, the cave, the dirt, the surface, and then we can have trees, but we're going to put the trees on their own. So we have to create those separately. But then we can have the foliage also as part of this, because that's not going to change. And we're probably going to like the background up here can be just sort of like that nice green, like really light green. Maybe something like this. And what do we have? Oh, okay, there's no fill tool to like paint in. Or like no what is it? No paint can to drop in. Oh, paint bucket tool. That's what it is. It's G. So throw you in there. Okay. Then we're going to want a much darker green for the foliage on top of this. So that would be something like this. And that would be a curved line tool. I'll need to figure out how to use that. So let's see, starting from like here. Oh, you're becoming like a circle. Maybe I just want a pencil. And I'll draw it in by hand. And actually don't need to do this with the mouse because I recently found the cable for my Wacom tablet, so we can just use this. All right. So starting here. Nice, like sort of hand drawn. It's not quite as wavy as like the original game has. You can do a little bit more, maybe. Something like that. And then our trees, we can ensure that the trees, maybe a little bit of the branches are visible, but what this allows us to do is come back to here. And now our tree foliage is that darker green. And I might want to make you even darker. Like that. No, that's like blue. Let's go down to like here. What? How's that even more blue? Maybe something like that. So like the darker green. And so this can be our basic level, as it were. And we're going to want to create other images to sort of like overlay on top of this. So if I choose this, and we want to, sure, we'll save you. Okay, this is the export. Let's export you first. Output file, you're going to be our forest. Or just like the background, I guess. I don't know what. Okay, let's try sizing by that. See how big it is. Layers. Okay, frames. Export you. And we should be able to see that in the resources. Oh wait, no. Where did I go? Where did I put that? You went to resource. Okay, quick spills resources. You went there. Oh, I didn't. Apparently, I didn't put it anywhere. This is background. PNG. Go there. 1000. Export you. Here's our background. We can see that this is 2,560 by 1140. So maybe a little bit too big for us. This is 2,560 by 1140. That kind of makes sense. What do I need? Calculator. So if I want 1920 divided by 256, 7.5. Like 700 maybe percent. Now you're 1792 by 1008. That's too small actually. So I need you by one more. Instead of 700, we'll do 800. And now you're 2048 by 1152, and we'll just I don't know how to scale this properly. Maybe I actually do need to set this to be 1920 by 1080 in the image. That might be good. Rami Ska, hello! What if I do that? What if I actually... Can I reset your size? Probably not. Canvas size 20, 1080. Oh, and that just made it like really small like that. I probably want sprite size 1920. 1080. Interesting. It mostly worked out. This down here is a little bit odd. So we go to black. What were you again? You're G. Drop you in there. Export you as our back. Oh wait, I need you to be just. I don't want you to resize at all. 0, 1. Huh. Oh wait, 100%. 100%. Here we go, 1920 by 1080. So we can use this image as our background, and I think this will be fine. We'll have our cave, we'll have everything else, and then instead of having to redraw this as a mesh, this as a mesh, this mesh, this is a 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 mesh, it'll just be one image, which is a huge savings for us. So in our image, in images here, we're going to bring in the background. So let's let background equals image new context, and then the path is going to be background.png. And then we're going to assert equal. Life image dot to RGB8 is the same as background dot to RGB8. Okay. This life image dot background. So you'll yell at us saying that background doesn't exist yet. So in image. All right, so you're going to be config dot. So background. Instead of like this background color, we're probably just going to want to like just background is what we're going to be grabbing at here. So that means we need background off of config. So we have this entire bedrock height, bedrock color, cave height. So we still need all these heights to like know where things are. And we probably want to do percentages eventually, but we were not going to have to take in like the bedrock color we won't care anymore about. The ground color, the surface color. Like none of that stuff we care about. Tree trunk is drawn separately, so we're not going to worry about that right this second. Background color. Any of the foliage stuff. And now we're just going to have background. Okay, so you'll be background here. Okay, so we have the background is a string, and then we just took away all the colors. So bedrock color, don't need you. Ground color, need you. Surface color, trunk color is fine. Background color and foliage, all the foliage stuff. All right, so I think this is still gonna work out. We have 10 errors though. All of our errors are in these game objects. Right, because we're now going to be getting rid of bedrock is gone, so you just delete you. Foliage is gone. Ground is gone. Surface is gone. Or surface background is gone, and surface is gone. Okay, then images. No field background on here. Here's background right here. Oh, because you don't want to be life image. Hold on. Your images dot background. And background. Okay, there we go. Let's see. No more images in here. Okay, so the map is now trying to draw all of these specific things out. So that's gonna be a problem. So bedrock, bedrock, foliage, foliage, ground, ground. Surface. Okay, you're more simplified. We don't have to store any of these things. Don't have to store any of you. We don't have to. You're all gone. You're gone. You're gone. All of you are gone. Okay, you're happy. Images. Config dot background. Oh, cannot move out. We don't want to move you. We want to get a reference. Okay. So that loads up, and I think that will make these tests work. Okay. Then I want to actually draw that image to the screen. So that's going to be in the main scene. For the main scene, we're going to draw the map. And the map probably shouldn't have to draw the player, right? The map is just going to draw... Was that true? Maybe the map will. Take a look at map. It's going to draw the tree trunks. Well, it doesn't have access to the images here. So map will need the images to just draw out the background. Okay, so that's going to come here. Reference to images. Then at the very beginning, so that it gets overwritten, we'll do a graphics, draw context. The drawable is going to be a reference to images.background, and then our params. We're not going to have any params whatsoever because it's just the full size. So draw param new, and that will draw out our background image for us. Main scene. We now need to pass in images here. That. Can I just do that? It's already a reference. Yes, it can. All right, let's see if this works. All right, so here's how that looks. The trees are all drawing in the background like incorrectly. And our player's positioning is a little bit off, but besides that, it doesn't look too terribly bad. Now, something that we can do is we could have the trees as part of that background, and now they're shifting, like the trees are shifting very subtly around, which is not too terrible of, like not bad. But if we really want to test to see if this is affecting our Raspberry Pi performance, let's go ahead and get this over to the Raspberry Pi. Now, what it could do is have like multiple images, like the foliage is an image, and then a tree, and then the rest of the background, and that would be 3 images instead of like a whole bunch of meshes, which is really helpful. Okay, so drawing an image as a background. Push you up. Back over to our capture card. Oh, okay, hold on. Undo. I forgot we had made a bunch of changes. That's not going to help out. So let's undo this. Untracked files. Let's do a checkout. Do that. We have this rasp info.txt. I think that was just like dumping out all the rasp info. I don't think we need to care about that. We could just remove it. Okay, now git pull. All right, now we can rerun this. I shouldn't need to like worry about that image anymore because we have that symlink already in place. And memory wise, we're not like we're doing really, really well. This isn't terrible, but it's not great either. We're still drawing a bunch of those trees, but it looks better. Let's see what we're at here. 287. So if I were to remove all the trees, and then we couldn't really do much with the player. So let's try removing the trees. So we can maybe have like a tree count. We could have this 0. And so look at that. Without any tree draws in there, that's looking a lot better. We're down to 44 milliseconds. So that's pretty good. I saw a huge number in there, but that was microseconds. Okay, so removing the pit can be really helpful also, so it's not displaying there. I think that when I'm on the screen without the pit, that shows. Let's go away until there's no pit. So I'm currently at 35 milliseconds without the pit. So that's like 6 milliseconds per mesh draw, but significantly less for the image draws. And then the player is pretty expensive. And I don't think I'm doing. I mean, so at that point in time, it's playable. And there might be some other micro optimizations that we can try. 47. Oh yeah, because I went into the pit area. So I could tell this not to draw any pit. So we can go into the map. So here's where all these pits are. We'll just say 0, 0. It's having to do a lot of math every single frame for the height of the player. Is that true? That's all CPU bound, and CPU is not our problem. So now we're down to 37, 36, 36. Okay. I mean, this is now in like a playable state because this might be only slightly faster or around the same that the original Atari was getting. The player image is a single image, and we're changing the draws over that. So if I were to go in and also, just out of curiosity, what is our %, and memory usage is not very much. That background image, I don't think that like doing a scale with it would make sense, like making it smaller, but I'm really curious. What's our? That's 4.9 kilobytes. It's hardly anything. So it sounds like basically just doing optimizing for lots of images, and that could be our scale method. Is have as few images as possible, and swapping those out is going to be a lot easier than doing meshes and other draws. And so if we take a look at our player, let's see, main scene for draw, we have the map draw, we have the player draw. And I think at this point, I think almost all of our time is now spent in player. And I can verify this by commenting out the player draw. So what is this going to be? This is going to be source, scenes, main scene. Okay, so map. If we take out player, and if I rerun this, we should get really fast draws. That's my thought. And so I wonder if there's ways for us to okay, yeah. So we have no player. I could still move the player around. Oh, look at that. 33 milliseconds. Okay, so actually, that's not bad. That's not didn't really change for us at all. 33 milliseconds, 32 milliseconds. Is VSync now taking effect? VI source initialize. We have we're specifically saying VSync false. So map is still taking a bunch of time. So if our main scene, we're drawing the map draw. So we're drawing you, telling the tree trunks to draw. If we don't have the tree trunks draw, and we don't draw the pit, if we just do that. And we're also not drawing the player. That should be a really simple draw. Like we're not doing very much. Okay, only drawing the backgrounds. Okay, so for you, quit out of this. Let's undo our changes here. Out of curiosity, what did we end up setting our all this stuff for? Initialize. 3.0. Let's go back to 3.1 for GLES. That might help. So update that too. GLES 3.1. Push. So I'm gonna pull you again. Pull. And we'll rerun you. So if this is still a really long time, then it means that that image is too big and it's taking too long to render out, because we're able to get those smaller images pretty nicely. And so if that's the case, then the kilobytes of image and sending that to the graphics card is a problem. Now, something else that I haven't really looked into that GGZ may or may not support is drawing very, like, not clearing the screen every single refresh. So if I move around, yeah, we're at 33 milliseconds still. So I'm really curious. Is there a way on GGEZ to clear only like part of the screen? Because right now we're clearing the entire thing, redrawing out the entire background, and then presenting that to the graphics card. I kind of want to take a look at the documentation for that. So if we have let's come to our documentation. There's no new version, right? No, 5.1 is latest. Let's go to clear. So clear the screen to the background color, but maybe is there a way for us to clear only like a specific area? GL and backend spec. Okay, so hopefully we don't have to implement it. Fields emitted. So that might be interesting to sort of play around with. Okay, so clear the screen to the background color. No other tricks that we can do. We could only do some of the draws each frame. So if I do like, okay, draw the background this frame. Well, no, the background needs to be always drawn. So there's present. Tells the graphics system to actually put everything on the screen. Okay, so for present, there's not really much we can do with this. Unsets any active canvas too. So, draw seems to be like draw is still really large. That image is maybe too big to pass over into the graphics system itself on its own. I can make the image really small. I can go back into A-Sprite. We could canvas size this, sprite size. We could lock our ratio and just like drop this down to like, I don't know, 1600. And sort of try this. Okay, so you're smaller now. That's not going to fill up the entire screen when I play this. I'm curious what this is going to look like. It looks okay. It looks like this. I mean, it's not terrible. We'd need to figure out what our scaling options are, and sort of set that to be what we need. Most likely, we'd want to have different images, like sort of pre-rendered images for each of the resolutions that we're going to be at. But if I did that, that's just dropping the image size down 4.9 kilobytes. Not really huge savings, is it? I'm curious if we went down to 800 by 600. 800 by 600 is not the right ratio. If I did a sprite size, so lock the ratio. If we do 800, that'd be 450. 800 by 450. And then we export you. Wait, still 4.9K? Okay, 1.45. Okay. Significantly smaller there. And if we take a look at what that looks like. Obviously, like, very small there. But we can see that our draw is like we're having many draws for each update. So I'm curious how this is going to look. Not look. Performance-wise, how 800... And that's still at the same resolution. If I set... Let's go in our config. If I set a resolution to 800 by 450, can you even do this? Yes. Okay, so that works. And that's super fast. It's like less than 1 microsecond on this computer. All right, so let's prime smaller everything. We'll push that up. Head over to you. This will be my last sort of test here. There's some other things that I can do off stream, like trying a different image for the Raspberry Pi. Do we change anything? No, we do not. Okay, so running that, it starts at 31 and then we go to 33 milliseconds. So like setting the resolution, setting the image to be really small, none of that is changing the draw. What else is happening in draw here? Scenes in our main library. So there's that main scene, we're drawing it, if we're in a main scene. And then we're figuring all this out. Now we're yielding after we print out. So it's like yielding that sleep isn't affecting us. If I don't do this, if all we're doing is clearing the screen and presenting, not even drawing. I'm actually kind of curious. What is this going to look like? Oh, look, what is it going to look like? It's going to be an empty screen. What is the performance going to be like? If we're still at 30 milliseconds, we might need to like, if I rip out the timing stuff, then we can't tell what our timing is. Maybe we could instead try just printing out the something else. Still at 33 milliseconds. Look at that. We're not doing anything over 33 milliseconds. So I have a bad feeling about this. I have a bad feeling that this is pretty fast now. Is our timing stuff screwing things up? Like if we take you out, we don't do any of you. If
All right, let's bring that beat back.
if we do everything here, heck, if we do nothing here and we just do a debug if self dot if timer, no, we're just going to put all of you back here. We're going to go into main scene, draw. You're not going to let me. Okay, there it goes. Main scene, draw. We're going to bring the player back in and draw the player out. Not measuring timings. Push you. So apparently my measuring of timings is like long. Either that or even doing the graphics clear and the graphics present is taking a long time. And it's possible that that's happening too. But let's try this. So back over here. Did I forget to switch screen while I was doing that? I'm sorry. Hit pull. We want to rerun this, and now we're going to be showing the player again. But we're not doing any timing, so we can't actually see the FPS. There's a few extra files that got changed here, so. My player is too small. We can't see that. We need to re-update the config.json. Back to here. Where are you? Our resolution needs to go back to 1920 by 1080. And let's also bring a sprite, undo a few times. All right, so that's those two. Full resolution. Yeah. I'm now curious if the problem is going to be the clearing and the drawing to the screen, like the present and the clear. I don't like it. Shouldn't be a big problem. Okay, recompile. Restart. Here we are, full resolution. We're moving decently fast. That's still feeling pretty slow though. And there's not much here. We're getting the timings on the update. But not really timings on anything else. Oh, what the timings are that small, then clearly it's not my timing code. That's not the problem. We're starting here at clear and right after present. I kind of want to move you up and just see how long does clear take. How long does the clear take every single frame? How long does it take here? It's taking like 3 microseconds. Okay. All right, we'll push you up. Oh, I'm still in the capture card. I was on the... Yeah, sorry about that. Let's see. Utsby, hello. This is a Pi 4, and we're getting interesting. Like we still have a problem. But we're zeroing in on what the problem is. So I'm doing a log out for the timings of just clear. We're ignoring everything else timing wise. And so we can move past here, and this is not bad. Come back to you. Okay, so draw. That's taking microseconds, like 10 microseconds. Okay, that's good. That's good. Let's that's how long the clear is taking. Let's try the present. So we're just gonna measure the present and how long that's taking. Okay, so you're pushed out. Okay, we're able to move. It's about, oh, I mean, we're not expecting this to be different. We didn't change any code. We're just changing our timings. Look at that. The present is taking 36, 35, 35, 35 microseconds. Oh, sorry, milliseconds. This is still software rendering, presumably. I mean, it's... If we take a look at our CPU is at 5%, at 2%. So, significant improvements CPU-wise. I can't tell... So, I think that, like, that feels like it's going through the graphics system now. But okay, that's like 34 milliseconds just for the present. Does that mean I'm sending too much to the graphics card at the same time? If you come back to main, this is just for, let's see, let's move startup here and there. So this is going to be testing how long each of this section is. Push that out, and so if it's true, it's taking that long to do the presents. That's where it pushes all of the changes to the graphics card. I wonder if we should do less pushes per frame then. I'm not exactly sure how to do that. Well, I guess we could stagger maybe the clear and then the draws. So yeah, look at that. My draws are taking microseconds to run. So it's not the player moving. It's not my calculations for updating the player. It's present. Present is taking too long. So given that present is taking too long, I know, progress, we know you should be sending much at all, the textures aren't being swapped, and you have next to no geometry. I know. It's a bunch of, and I even removed all this background now. Utspi is just a single image. I now have, I removed the trees. So in Aseprite, we just made this. This is basically an image, and then with the player on it, and the player is moving. So I don't even know how to do less presents. Well, Okay. I know how to do less presents. VI source lib. If we go down to our draw, a present may include a stall waiting for a vsync. I told vsync, like I explicitly told it to be false. Because if we take a look at our code in initialize, we're having it, like we're explicitly saying vsync false. So unless it's ignoring that, we shouldn't have a problem there. All right, so what I want to do is, you know what? This is probably just easier, probably faster, and a lot easier to do over here. In our main library, we just don't do this all. We're clearing the graphics, setting it to black. And then we're presenting. And that's it. We're yielding, but we're yielding after the end of our measurements. This is literally doing nothing. This is just clearing the screen and presenting a cleared screen. And that's it. If this is still giving us 30 millisecond times, it just might be that we're going to run with a 30 millisecond game, but it might also be something else. You have to make dinner. Now you're on a Pi 4, you have options like Ubuntu available to you. I know, yeah, I think I'm going to try some of those, and we'll see. All right, so that being done. What are we doing? I'm over here. Have a great dinner, Utsby. Yeah, I'll be trying Ubuntu too. And maybe some of the other operating systems that are available to me, like officially, would be nice too. They might work as well. All right, so we're not doing any of this stuff. We head on over 33 milliseconds. None of my code is a problem. This is all present. Present is just taking a long time. And I'm not sure. We're on GLES 3.1, which should be fine, but for some reason it's really slow on the Pi. Well, I will try installing Ubuntu. Maybe like I can try like the 32-bit full desktop version. I can also try like a 32-bit server or a 64-bit server, and then installing graphics system on top of it. Maybe not like full GNOME, but maybe something a lot lighter, and trying running that there. Those could all be like really good options to give a shot at. That being said, I think we made like we made some progress in like understanding exactly what the problem is. Game wise, it's playable at 30, like at 40 or below frames per second. It's not great, but it's something that we can still do. So we might not be posed yet, but we might, like, there's some things that we might be able to try. But we might have to like sort of think things through also differently. All right. The things were moving like fast earlier. I have to like, I don't know what's going on with it. Why are you slow now? I'll try some different configurations. Anyways, we'll be back tomorrow morning. Tomorrow morning for more programming of this game. Hopefully we'll be on to like actual feature stuff again. Maybe not. Maybe we'll just be stuck in our Raspberry Pi forever, or maybe we'll just be like giving up on a Pi altogether. I don't know. And then just figuring something else out. Maybe going back to figuring out how to like deploy this onto their system, or maybe having to build this in new technology. So anyways, with that, thank you so much everybody for stopping by. I'm gonna switch over to my ending screen. I'll be back tomorrow morning at 7 a.m. Mountain Time for about an hour and a half until 8:30 in the morning. That's when I have to head off to work. And that will be every single weekday morning. Thank you again. Thank you, Chat Soda, for being here. Thanks for watching. And I hope that you all have a great rest of your day. And I'll see you all next time. Bye.